Hi, I'm Kacie Quintanilla, and I'm going to do 4 definitions. Absorption. Absorption refers to the material, structure, or object absorbing sound energy when sound waves collide with it. Examples of this would be soundproofing your studio walls with soft materials like cloth or wall treatment foam. Diffusion. When sound energy is spread evenly in an environment. Example, to control echo and reverb in a room, you could use diffusion like a bookshelf. Reflection. A change of direction of a sound wave reflecting off a surface in the same angle it hit. This causes reverb and echo. Reverb. When a sound is reflected, causing a large number of reflection to build up and decay.
Alright, I'm Kacie Wood, and I'm going to do the last 3 definitions for you. So the first one we have is direct sound. It's sound that is not colored by the rooms, reflection, diffusion, reverb, etc., etc. Standing wave. So the next one, which is a wave that remains in a constant position. And then early reflections is sound that arrives at the listener after the source of the direct sound, but often before the full sound of the reverb and whatnot.
I'm Cody Magella. I'm Rutherford. Today we're going to be using the formula frequency equals velocity over wavelength to find the standing waves in this room. First we're going to measure all the parallel surfaces to get our wavelengths, and then apply them to our formula, and we'll find out what frequencies those wavelengths are occurring at. Okay, so take that. Right. Okay, let's write it down. So for the first wall, we got 27 foot, 10 inches. Alright.
Next, we need to go 23 feet, 8 inches.
Alright. The ceiling.
Next for the ceiling.
7 foot 4 inches. Alright, so first standing wave should be 27 feet 10 inches long. Second should be 23 feet 8 inches long, and the third one should be 7 foot 4 inches. We're now going to convert those to numbers that we can put into our formula and calculate the frequency of the standing waves. Alright, so we've got our wavelength measurements converted into decimals so we can use to calculate the frequency. So instead of using 344 meters per second, we're actually using the 1130 feet per second. So in order to calculate the frequency for the first standing wave, we have 1130 divided by the 27.83, which gives us
Equals 40.6.
all right, so we have a frequency of 40.6 hertz. And for wave 2, 1130 divided by 23.6 feet gives us a frequency of
47.88.
47.88 hertz. And the last, from floor to ceiling, we had 7.3 feet, so 1130 divided by the 7.3 gives us
154.79.
154.8 hertz. Now, if this was a control room, or if we had instruments that, or voices that would actually create frequencies that are the same as these, we would get some feedback, so we would want to take the EQ and drop these frequencies out of our mix.